Next, we have GIS for game engines. Annie Nguyen, an intern in our area, will be giving that. Annie is a student at Stanford University. She recently graduated with a bachelor's in electrical engineering, go EEs, and is currently pursuing an MS in computer science. She joined us last summer, and we had a lot of fun with her then, and she is continuing her work this summer. Annie, we'll transfer the mic to you, and the floor is yours.
Are you going to be setting up in the back?
Actually,
because we need it.
Okay. Can I do this?
Yes. Thank you.
Sorry.
No worries.
Okay.
So first and foremost, what is GIS? I might be calling it GIS throughout this presentation. This does not represent my opinion on whether or not you pronounce GIF as GIF or GIF. But for those of you who don't know, this stands for Geographic Information System, and it is a system that basically creates, manages, analyzes, and maps data. Now, GIS can take on a wide range of data and can synthesize them into different representations, but generally speaking, it needs location data and descriptive information, such as elevation, population, or terrain. It then helps create unique maps that help us visualize the components and connections between those sources of data. From that map, we can then analyze the data to find larger connections and correlations that matter to us in our projects. We can find patterns between the relationships, understand the geographic context of those relationships, and better communicate these discoveries to others. As you can imagine, this can have a ton of applications in various areas, such as public safety and transportation, health, education, or the government. In particular, using GIS in XR applications has the potential to convey that information in an interactive, immersive setting, utilizing the strengths for both compelling experiences. So why is this a concern for game engines in the first place? Well, as mentioned earlier, most, if not all, XR applications are made in game engines, and with the primary ones being Unity and Unreal Engine. Many game and online maps use a spherical model of the globe, with the online standard being Web Mercator. This model basically simplifies the calculation from ellipsoidal to spherical, which creates distortion in the representation of land masses and bodies of water, but is generally not noticeable for lighter uses. However, depending on the level of detail and accuracy needed for your application, it can matter a lot, as the approximation can be thousands of meters incorrect. In particular, game engines aren't suited for the size of and calculations for GIS data, as they use the Cartesian coordinate system by default. Like online applications, they are limited in processing capacity and will often optimize for better overall performance, which makes sense so that it can save resources for more important tasks and overall compromise for better graphics. Therefore, game engines don't natively handle those large distances and accurate values needed to support a GIS. Unity and Unreal currently each have workarounds, one of which James has actually mentioned earlier. Unity has the high precision framework, which, and I quote, allows Unity to render very large worlds and addresses the limitations of the single precision floating point system. Once again, as James has mentioned earlier, this is default to how Unity positions objects and understand where the player is within the world. And this is currently available as a package add-on to whatever project you are using. Unreal Engine uses large world coordinates, and I won't need to say too much about it, but it basically does the same exact thing and is currently available only in Unreal Engine 5, so you would have to consider upgrading from any project that's in Unreal Engine 4. So considering how GIS fits with game systems is important for designing and developing accurate and immersive applications for professional use. So when it comes to deciding on what to use in a game engine, there are a few things that you should consider. First of all, what data is it referencing? How does it show that data, and what do you want it to show? What does each API do, and how might the tool help you achieve the result that you want? And just general programmatic considerations for your project. As mentioned earlier, Web Mercator and similar data is not good enough for realistic immersive experiences, and in fact, the DoD through the NGA has declared that Web Mercator is unacceptable for any official use, so that's completely off the table. So for developing within game engines, we want a tool that supports other references. WGS 84 is considered the minimum standard that these projects and their data should be held at, and it provides a good base, accurate way to deal with Earth and global calculations. Ideally, also, a good library will support multiple spatial references and allow conversion between them to give the most amount of flexibility for a developer. There are applications where someone might want to use a different coordinate system, but making sure that WGS 84 is supported at the bare minimum is important. Finally, in general, the library should have good documentation on the use of references, as any good engine or plugin would have. The next consideration, map visualizations, depends on what you or your audience wants to get out of the data and what you need. Some applications only need to focus on a simple map, but a developer might want to add terrain layers or satellite imagery in order to make the visualization more compelling to others. The most common example that we've all had dealing with is Google Maps. The complexity of the map detail can also vary depending on whether or not you want simple building visualizations or something that's up close and detailed. For example, Cesium for Unity as is has approximate models and textures for the buildings, as you can see in the bottom center image, especially if the data is streamed directly online and live, which might suit some applications, but in case you wanted more detailed tiles, you might consider using their photorealistic 3D tiles along with their base API. There also might be the consideration for custom layers if you wish to display particular building or land features that you custom made for your project. If so, you want to make sure that custom code and models is compatible, or you would want to look into potential customization options through the API. Of course, ease and utility of the plugin are important things to consider for a developer. Depending on the API, there are multiple ways to load the data, and some might provide online and or offline capabilities. So I can personally speak towards Cesium and ArcGIS for Unity, where Cesium partially relies on streaming data live with the option to load local assets using a local host, while ArcGIS is capable of loading both online and offline data using either ArcGIS Pro as the source or using a local data file. It's important to note that both require developer keys for access, so please set up your project online. I have made this mistake more than once, and it is quite frustrating when you get to it. Each API will, of course, also control and display the upload and access of globe data differently. So Cesium has tabs for adding or uploading new data, and it appears as parented game objects with components for parameter customization, such as origin, location, tile source, and detail. ArcGIS is quite similar in terms of the game object structure, but it has detailed tabs in the editor UI for customization. Of course, this interface changes between Unity and Unreal. I like to make the analogy that Cesium sort of feels like Unity in the sense that it's kind of more plug and play. It's very nice and easy to use, whereas ArcGIS provides a lot of utility and customization right off the bat. There could also be the capability to load custom tiles or data, such as with the photorealistic 3D tiles that I mentioned earlier. Your application might also need to use the map to navigate from one point to another. Some APIs can provide this and at varying ease of use. So for example, you might want to make an AR or VR application where you're giving a tour of a city or parts of the globe. So this is where that might be important. And so programmers would be at a clear disadvantage if you had to custom make this all by yourself. So it's in your best interest to have a tool that has a built-in accessible version of this program through the editor interface. The API may or may not also help the user do spatial analysis for their needs. So this image is just an example of, say you wanted to find particular geographic locations starting from some center city and searching, say, a mile, 2 miles, 3 miles out, etc. Your application may be beyond simple visual analysis, and having an API that allows the derivation of new information from multiple sources would make that process significantly easier than, once again, tediously working and custom making something for yourself. Last but not least, your project might want to have search capabilities, whether that be finding specific points of interest or related points around that point of interest. Once again, finding a tool that fits your needs for that. Finally, there are also some general programmatic considerations for your project, such as considering supported devices. This can be a limitation from the game engine itself and what it can support, although that technically is not a big case nowadays with software being adaptable, such as with OpenXR, but also from your tool of choice and the compatibility with hardware. As many XR developers know, choice and awareness of hardware limitations is critical, particularly at the start of a project. On a development team, the game engine of choice will affect what GIS tools are available and which ones are better for the project purposes. So depending on the situation, although what Blake said earlier about choosing a game engine for your team definitely applies first, depending on the situation, the team might want to stick to their chosen engine and then choose the tools that are compatible with that. But in some cases, your tool of choice might just be the thing that you need, and you might consider switching over game engines for that. So it really is depending on your team and your project. Of course, country of origin is important, as we want to be using maps and data from non-adversarial parties and countries. And for cost, the project should consider whether a one-time purchase or a subscription license is best for them, or if a purchase is actually necessary at all. So Cesium happens to have a premium and commercial license, subscription option, with the option for a customized plan, whereas ArcGIS has a base subscription that you can add extra utility to, which of course would increase the cost. Lastly, your choice of tool can depend on if you need to stream data live from the internet or from local files. And so the flexibility and size of data can be considerable factors depending on the application and your chosen headset. And so you would want to choose a plugin that offers exactly what you need. So here are a few GIS libraries available for game engines, ArcGIS and Cesium, as I mentioned earlier, as well as Mapbox, which is more like a large suite of applications outside of XR use as well. So you can primarily use this for online map-related dev, but also for XR-related dev. Online Maps is a one-time purchase Unity package that is multi-platform. So if your team is strictly a Unity-based team, this might be a simpler solution for you. Blackshark AI for Unreal and Omniverse is a little bit more dynamic. It synthesizes multiple sources of data to generate an accurate digital twin of the globe to use. So this is perhaps a little bit more dynamic and customized to what you want versus, I believe, ArcGIS and Cesium use kind of their static databases. So it's not as dynamic. There was the Google Maps platform gaming services for Unity, but that has since been deprecated. So don't go searching it online unless you want to see old documentation. But in summary, there are a number of important factors that go into choosing the appropriate library for your application, from what is available in the software to larger project considerations. But most importantly, of course, try before you buy. Most, if not all of these solutions mentioned, offer a free trial with decently thorough documentation and project examples. So exploring them on your own will offer you and your project the most feedback. So this was a relatively brief talk. So you're welcome to take a break. I'm also open to answer questions, and Blake here also is here to answer questions.
Questions for Annie?
Going once, going twice.
So for some, like, I guess, more primitive use cases that are out there commercially right now, I guess, like, more primitive inputs, like Microsoft Flight Sim, they stream assets and the global data from their own Azure server that does AI processing and modeling some textures and streams into your local machine. How does, how does this apply for 3D models as well as, like, maybe, landmarks or points of interest?
Yeah, I can speak briefly, like, as a high overview, because I personally investigated ArcGIS and Cesium for Unity, but perhaps James or Blake could speak more to the details. From what I understand, it has a lot of, like, preset data that you can use. So whether or not you're using either database, they probably have their own provided models. Either it's like rendered kind of live when you zoom in on the map, or it's like a separate data file with assets for a particular location. Because it could be the entire globe that you're trying to stream in data-wise, or it's just a particular patch of the globe. So it seems, at least to me, that ArcGIS and Cesium can provide a lot of those initial assets. So outside of what Microsoft might be doing independently, this is kind of available across the main game engines, being Unity and Unreal. So it provides a lot of that utility so that you have more flexibility as a developer. And these APIs also happen to allow custom loading. I can say this particularly for Cesium. There is an example project of them just uploading one of their own personal models to say, I believe the example was, let me find this football stadium, and you're able to query it, and it pops up where the football stadium is and has a custom 3D model for that. So you have a bit more utility there. I personally don't know too much about the Microsoft end of things, but that's kind of my impression. Blackshark. OK, so if it uses Blackshark, then it is a little bit more dynamic in that regard, whereas ArcGIS and Cesium use kind of their data sets / any data set that is applicable or plug-in-able to them. Yeah. Queens, well, you have plenty of time for a break. There are snacks outside.
Any other questions? Join me in thanking Annie.
Oh, thank you.